All right. So again, we're talking with algebra. We're trying to find x. Now we can always try to guess, but it's going to be pretty hard. So we're going to use these special tricks that we've been learning about to try to come up with x in a systematic way so we don't have to sit and try to guess for all time. So the first thing we want to do, let's get rid of the parentheses. And we do that by distributing the minus sign. So we have a minus goes to x, that makes it a minus x. I have a minus and a subtract 5, that's going to be a double negative, which becomes positive. So we have something like this. And we can combine like terms. We have a positive 2 and a positive 5. So we can combine them into a positive 7. Because 2 and 5 are type constants. X is type X. So when they're different types, they won't combine. Now, we want to get x by itself. We're going to try to balance x on one side by itself with some number, and that tells us what x is. So we're going to do opposites. The opposite of adding 7 is subtracting 7. And what we do to one side, we have to do to the other. So when we do the opposite, they cancel out. And 14 minus 7 is going to be 7. Now, this is a tricky situation. Negative x. We can treat this, and this is sort of an algebra thing. Negative 1 times x. When you have a minus like this, you can treat it as negative 1 times that variable. So how do we get rid of it? We want to get x completely by itself. Well, what we can do is do the opposite. If we're multiplying by negative 1, the opposite of multiplication is division. So we divide by negative 1. So these will cancel out. You have positive 7 divided by negative 1. And so what that'll give us, positive divided by negative, when the signs aren't the same and we're multiplying and dividing, the answer is going to be negative. Negative 7. Which would be a hard thing to guess, to be honest. So questions about that? Let me show you another one. Now, a lot of the algebra, it takes practice. This is something that's worth putting time into until you know you've got the hang of it. Till you feel confident. So let's say we have this. All right. Now this is a mess. Now what we want to do is we want to divide and conquer. In other words, let's do this step by step. Let's not try to do all of it all at once. What's one thing we can do? Let's get rid of parentheses. And the way we get rid of the parentheses, we distribute. So we're just going to get rid of parentheses at this point. Now, when we distribute a number with a minus sign in front of it, it's going to take the minus with it. Same thing here. So we're going to get 2 times x I'll just write it as 2x. 2 times 5. We have to subtract 10. Now we get to this. Negative 3 times 2x. Negative 6x. Then negative 3 times negative 8 plus 24. Then we have 16. Negative 6 times 4x. Negative 24x. Negative 6 times negative 3. Negative times negative is positive. Positive 18. So now we're going to combine like terms. 2x, a negative 6x. So it's like you have $2, then you lost $6, or you, let's say you did this, you didn't lose 6. Let's say you had $2, and golly, for some reason you owe somebody $6. So what that means is you're going to pay them the 2, you're still going to be short 4 minus 4x. Or you can think of it like this, it's 2 degrees, then it drops 6 degrees more, it gets 6 degrees colder, it's now negative 4 degrees. So those are the type x's. We can combine those. You have type constants. This will be 14. Now, these are type constants, positive 16, positive 18, positive 34. Now, this is an unusual situation. In the past, it always worked out that x was on one side. Now you've got x on both sides. So what can we do? We need to cancel x on one side. So there's only an x on the other side. So how could we cancel? We do the opposite. So if they're subtracting 24, the opposite of subtraction, addition. We add 24. So we have 20x plus 14 is 34. Next, we want to get x by itself. Well, now we got x on one side. Perfect. Next, what we're going to do, we want to get x by itself. Now, if you recall with PEMDAS, we do parentheses, then exponents, then multiplication, division, and then we do addition, subtraction. But when we do algebra, so that's arithmetic, algebra, AL, goes in the opposite direction. And instead of doing the operations, we do the opposite. We cancel. We're going to cancel subtraction and addition first, then cancel multiplications and divisions, then exponents and roots, and then we deal with what's ever inside the parentheses. So usually in PEMDAS, we would multiply if we knew what x was, and then we would add. So for algebra, we're going to do the opposite. We're going to cancel adding and then cancel multiplication. So the opposite of adding is subtraction. And then when you have a number next to a variable, that means multiplication. There's a little invisible multiplication sign in there. So we divide by 20. And then something divided by itself, well, that's equal to 1. So questions about that? So the last sort of solve for x kind of activity that we're going to look at involves formulas. Now, we looked at formulas earlier. And a formula usually involves assigning a variable or some variable's values to find the value of another variable. Here, let me show you. So just to review, we were interested in, say, a formula like this. Something like this. So what we might be asked to do is find A with B equals 2 and C equals 7. Now, we've seen this before. We've seen some very complicated examples of this. But just to kind of review, we have B plus C. We're going to replace B with 2 and C with 7. And so A is going to be 9. So that's what we've done with formulas so far. By giving a value to B and C and then working out the arithmetic, we found a value for A. Now, what we're going to do is a little different. In this case, when we're going to solve for a variable in the formula, we're not going to be assigning values to the other variables. What we're going to be doing is isolating one of the variables. So we might be asked to do this with no numbers to work with other than what we have in the formula, which in this case, you could say there's invisible ones in front of these, but that's about it. So how do we do this? Well, what we're going to do is we'll treat B as if it's the only variable. So we're going to treat B as if it's the only variable, and we'll move the other variables as if they are numbers. And we're going to move them away from B is what we're going to do. We're going to put the spotlight on B in this case. So we're going to treat B as if it's the only variable. Then we're going to move the other variables as if they are numbers. And some of this can get kind of tricky. So we'll do some examples with this. Any questions so far? All right. So we're going to solve for B. So we're going to treat B as if it's the only variable, everything else are numbers. So we want to get B by itself. Well, we've got this plus C here, so we got to cancel the plus C. Well, the way we do that, the opposite of adding C is subtracting C. So we're going to subtract C from both sides. So we know this is going to cancel. This will go away. But what's going to happen here? Well, We don't know what A is, and we don't know what C is, so we can't turn these into a number. So the best we can do is just sort of make what they call, or I don't know if you've heard the phrase before, a rain check. We're just going to call this A subtract C. And someday if someone comes along and says, oh, put this number for A, put this number for C, well, we can do that. But until that day comes along, we're just going to leave this in limbo, which is fine. And so we find out that B is equal to whatever A minus C someday turns out to be. No pun intended. So that's the best we can do, and that's fine. And that's exactly what we're looking for. So let me show you another. Any questions about that? All right. So we're going to solve for I. So that means we're going to give all of our attention to I, so to speak. I is going to be treated as if it's the only variable. And when you have variables next to each other like this, again, this is what algebra does. There's an invisible multiplication sign, and for some reason we don't write it in, but there it is. So what we're going to do, we got to do the opposite of multiplying by r. Now, subtraction and addition are opposites, but then multiplication and division are opposites. So the opposite multiplication is division. So this will go away. It'll cancel. And we have this. So what we're going to get is we're dividing v by r, and that's the best we can do until someone comes along, gives us a number for v and a number for r. We can't do any better than that, and that's fine. Now in algebra, they like us to write division as a fraction. So we'll write division like that. And so this is going to be our answer. Questions about that? All right. So I want to share with you a trick, and I'm going to call this the reciprocal trick. And this has to do with fractions. And it says this: the product of a non-zero number and its reciprocal is 1. I'm going to talk about what a reciprocal is, but you'll see this term every once in a while. So what is a reciprocal? You can think of it as the flip. So in other words, if you have 1/2, the reciprocal is 2/1. If you have 3, well, any number you can write is having a denominator of 1. This is where this trick comes back again. And so the reciprocal is 1/3. You have 3/4. Reciprocal is 4/3. So what happens when you multiply a number to its reciprocal? Well, let's take a look. 1/2 times its reciprocal. Well, if we multiply fractions, we get 2 times 1 is 2. 2 times 1 is 2. And sure enough, just like the little trick says, you get 1. Well, okay. And if I'm going too fast, let me know. So let's try this other one. Take a look at 3. 3 times its reciprocal of 1/3. Well, 3 we can write as 3/1 times 1/3. We multiply across and fraction multiplication. We get 3/3, and sure enough, it's equal to 1. Okay. Finally, for 3/4, take 3/4 times its reciprocal. We get 3 times 4, or 4 times 3. That's 12/12. And sure enough, you get 1. So the trick's valid. You take a number times its reciprocal, you get 1. So how does this help us with algebra? Let me show you. So any questions about this? All right. So let's say we have 3/4 x equals, let's see, 8. 6. We'll go with 6. We could divide by 3/4. That would be perfectly fine. This is 3/4 times x. So we can divide by 3/4, divide by 3/4, and that'll work. But we could also use the reciprocal trick. If we multiply 4/3 with 3/4, and what we do to one side, we have to do to the other. Well, we know, don't forget x. Well, we know if we multiply a reciprocal to the number, we get 1. And if you do the multiplication here, what you're going to get is 8. Now, here's where the power of this trick really comes through. 1 times a variable is just that variable. And so we get x equals 8. So we can make this a kind of a shortcut. In algebra, a number times its reciprocal gives 1, or cancels that number. So we can use multiplication by reciprocal as a way of cancellation if we do it right. So let me show you what this looks like. Any questions so far? All right. Now, if you're not sure about this method, what you can do is always just divide. So if we're multiplying by 1/2, we can always divide by 1/2. That will work, and we divide 1/2 on both sides. But I'm going to use the reciprocal trick. The reciprocal of 1/2 is 2/1 or 2. So if I multiply both sides by 2, this will cancel. We'll have 2a equals b times h. Again, when two variables are next to each other, it means multiplication. So again, we're treating b as if it's the only variable. So the opposite of multiplying by h, dividing by h. When we divide by h, we got to be careful. We're actually dividing the entire side by h. The entire side. So we're dividing 2a, the whole thing, by h. And that's going to give us b. Questions about that? All right. So let me show you another one. Now, I would like to show you this, though. Let's say you're not comfortable with the reciprocal trick, and you just want to divide both sides by 1/2. What if you just want to keep it simple? Well, that's perfectly fine. So we're multiplying by 1/2. We can divide by 1/2. And then this will cancel out. Then we do the same on this side. And so what happens on the other side, get a divided by 1/2 equals b times h. So you don't have to do anything with this reciprocal stuff. You can ignore it if you want. And we're going to do fraction division. So we give this a denominator of 1. We flip this to be 2/1. Division becomes multiplication. So we multiply across. Get 2a over 1 times 1 is 1 is b times h. Now 2a divided by 1 is 2a. And then we have b times h. And then finally divide both sides by h. we'll get 2a. Again, we're dividing the entire side by h. We have 2a over h is equal to b. And that's going to be our answer. So you could do it either way. You'll get the correct answer. So let me show you another one. Something about this dividing both sides, we gotta be really careful with this. And again, if I'm going a little fast, let me know. So let's say we have this. And we're going to solve for b again. Now again, we want to get b by itself. So we gotta, again, kind of work backwards. We gotta think the opposite of PEMDAS. Usually we would multiply by b, and then we're treating this like it's a number. So we'll treat 2a like it's some kind of number. So usually with PEMDAS, if we knew what b was, we would multiply these two and then add this number. But we're doing algebra. So we're gonna go the opposite. We're gonna cancel adding this quote unquote number 2a, and then cancel the multiplication by 2. So the opposite of 2a is negative 2a. So we get p minus 2a is equal to 2 times b. Now this is where we gotta be a little careful with our division. We're gonna recall we're dividing both sides by 2. And it's both sides. Now it just turns out this side's very small. So it only has one term, but when we do these operations, we're actually applying them to the whole side. So this will become p minus 2a, the whole side divided by 2, and that's equal to b. Questions about that? Now, when we do addition and subtraction, like when we do something like this, I've always been lining it up with the term to show that it's canceling. Technically, what's going on, I should actually be writing it over here. And the reason is we're subtracting 2a from both sides. Now, for convenience, just to show that these cancel, I've been writing this underneath that. But that makes it look like I'm just subtracting from this term and ignoring this. I'm actually subtracting it from the whole side. And because of like terms, the term in here, they're going to cancel and leave this anyway. So it doesn't make any difference. I could put it here or put it here. I'm going to get the same result because when I combine like terms, the minus 2a and the 2a will cancel, leaving this. But where this becomes really important is when we're multiplying and dividing. When we get to this line, divide this side by 2, we're dividing this side by 2. And now we got to really remember, we're actually doing these operations to entire sides. And so that's why we cut this side in half. We have to cut this entire side by half. And that's why we're getting this. Any questions about that? Well, let me show you one more. Ooh. Now this could be a tricky one. Now we want to solve for p. Now the thing to keep in mind, this here is a giant division sign. So we could think of it as RP in parentheses divided by R plus 2 in parentheses. So the thing we're going to do, we go backwards through PEMDAS. Usually through PEMDAS, we do parentheses, parentheses, then divide. We're going to go the opposite. We'll undo the division, and then we'll do whatever we need to compute inside the parentheses. So the way you usually see this written in algebra is they'll keep it like this. And then we'll take the opposite of dividing by R plus 2 is multiplying by R plus 2. And what we do to one side, we do to the other. And so what we'll get is, and we usually put the t in front, but you could put the t, just leave it like this if you wanted to. Again, these will cancel because they're opposites. We get RP. One last thing, opposite of multiplying by R, divide both sides by R. We're actually dividing this side by R. And when we do, there's only, these are going to cancel. We're dividing this side by R, the whole side. And so we get our final answer like so. Questions about that? So the next section we're going to look at, these are word problems. And what I'm going to go over is there's two things to cover in this section. One is the language of algebra. And there's a chart for this. I'm going to go through some of the words on the chart. But if you have your textbook in front of you, it's going to be page 485. So we've got the language of algebra. So there's some key words here. And the idea is that we could have a sentence. And it's going to be, this is going to be for English sentences. And there's certain words, if you're using English, there's certain words that tip off when you use certain mathematical operations. So if you see words like equals, is, was, and there's more, you're dealing with an equal sign. If you see plus, sum, increased by, and there's others, you've got a plus sign. If you see minus, subtract, less. And then usually, got to be careful with less, because this can also can mean a comparison, like greater than or less than. But in this case, it'll be less, and then there's some amount or a variable. Well, that's going to be subtraction. You have times product of. This is going to be multiplication. There's the x multiplication. Divides quotient. That's going to be division. You might see something like twice or doubled. This means 2 times. You might see something like a squared or the square of a. Well, it means this. And the same thing with cubed. If you see a cubed or the cube of a, you'd have a with a 3 as an exponent. But again, these, you're going to find these on page 485, and there's a bunch of them. So how does this work? Well, what we want to do is translate sentences. And these are common words, at least in English, that are used to express mathematics. So what will come up is something like this. The height of a tank is 1.4 times the width. So what we're going to do is go through and edit this. Look for translations we can make. So key one is. This is one of the words that translates to an equal sign. And then times is multiplication. So now we can rewrite this. The height of a tank is 1.4 times the width. Now in math, we try to come up with abbreviations for quantities. And that's oftentimes. So we have the height of the tank. We can do this. Let h equal the height of the tank. And then we're going to let W equal the width. Now, I don't have to use H, and I don't have to use W. I could use X, and I could use Y. That's perfectly fine. I'm just going to choose a variable that kind of reminds me of height and one that reminds me of width. But you could use X and you could use Y. You don't have to use H and you don't have to use W. So now what we have is the height of the tank, which we're calling H, is 1.4 times, and we're calling width W, 1.4 times W, or H is 1.4 times W. Again, in algebra, we let the multiplication sign become invisible. And that's going to be our answer. Questions about that? So let me show you another one. The sum of two weights is 167 pounds. The sum of two weights is 167 pounds. Well, again, let's do our translation here. Is becomes equals. So where does this get us? Well, not all that far. So the sum of two weights is 167 pounds. Well, I think it does get us somewhere, because now we're starting to see the equation take form. Now, what do we do with this? Well, the word sum, that means we're adding two things. What are we adding? We're adding two weights. Now, what do we know about these two weights? Well, other than adding them to get 167, we don't know anything. We don't know if they weigh the same. We don't know if they weigh differently. So what ends up happening here is we're going to let the first weight, whatever that is, we're going to call this X. And the second weight, we're going to call that Y. So this means when we have the sum of the two weights, this will become X plus Y equals 167 pounds. And that's the best we can do. Questions about that? All right, so let me do a complicated one here. More complicated. The weight of a metal cylinder is approximately equal to 785 thousandths times the height of the cylinder times the density of the metal times the square of the diameter. Whew. We got to come up with an equation here. So there's this approximately equals. And that's something that, let's start taking this thing apart. Approximately equal to, we'll just call that equals. Now we have a lot of things flying around here. We have a weight of a metal cylinder. There's a height of the cylinder. There's the density of the metal. Let's start converting these into variables. So weight of the metal cylinder, let's call it W. Oh, and there's the is. Let me cross out the is. That's part of the equal sign there. Now, times, that's multiplication. Got a dot. Height of the cylinder. The height. Let's just trim this down. Let's call this H. Let's see here. Oh, there's another times. So we can do that. The density of the metal. I'm going to call this M. And the reason I'd be tempted to call it D. There's another times. But then we have the square of the diameter. So I'm going to call this, the diameter is going to be D, but it's the square of the diameter. Now, if I look that up on page 485, the square of A was A squared. So the square of the diameter, I'm going to call the diameter capital D. It's going to be squared. Whew. So any questions about this editing that we've just done? All right, well, let's put it together. Let's see what this mess turns into. So we got a W. We've got an equals. Equals. Then we have this number. Well, this one survived. Seems like everything got crossed out. 785 thousandths. There's a times. Then there's an H. And then we have our H. There's another times. Then there's this, which became just an M. And then there's another times after that. And then we have the square of the diameter. I'm calling the diameter capital D. So we're squaring it. D squared. Now again, remembering in algebra, we make the multiplication signs invisible unless we're multiplying a number and another number. But if it's variable and variable, or number and variable, make it invisible. And that's going to be our answer. Questions about that? Excuse me. So that's how you can translate, at least in English, using words that quantify or represent quantifications in English. Last thing in this section, story problems. Now you've been doing story problems already, but these are going to be with algebra. And these are going to be, we're going to look at some steps for story problems. So what they recommend is, well, first off, read the problem. I mean, that's pretty true. You want to read the problem before you solve it. And you want to know, and this is key, you want to note knowns and unknowns. This helps us check if we understand what's going on. Next, here's the algebra. Remember, a variable is a number. We just don't know which one it is. We assign a variable to an unknown quantity. And then we might write any expressions depending on that unknown quantity. Then we're going to try to write an equation. And this will come from knowledge that we have about what's being asked in the question. Then we'll solve. Now 5 and 6. So 5, you sort of, in a way, it's kind of reflecting on your answer. And you sort of say, you see different ways of doing this, like put it in your own words. Sort of, you'll say sometimes write a sentence using the question with the answer that you got. But basically, and this is what it says. It says answer the question, which seems kind of peculiar, but what I interpret this as meaning is, does your answer make sense? In other words, if you're doing this question and you're supposed to find an answer in feet, but you got an answer in degrees, that might mean something went wrong. And so you want to sort of check to see if this actually is answering the question to begin with. This is a sensible answer. Like, let's say you're trying to figure out, you say you make $10 an hour and you're working at the local Subway and you work 10 hours. So how much money did you make? And you come up with an answer like $1. And it's like, well, that doesn't make sense. I mean, you make $10 in just 1 hour to begin with. So see if the answer makes sense. And then finally, check the solution. And this is a lot of this, did you make a computational error? Because you might get an answer that kind of makes sense, but it still might not be correct. So you can check your computations, make sure that those worked out okay. So let me I'm going to do a couple examples, and then that'll be it for tonight. Just to illustrate this technique. The powerful part of it is knowing an unknown, or knowns and unknowns. That really helps clarify where you want to go with this problem. So let's say we have this. Two metal castings have, or weigh, 84 pounds. One weighs 12 more, slip in the pounds there, 12 pounds more than the other. How much? Does each weigh? So two metal castings weigh 84 pounds. One weighs 12 more pounds than the other. How much does each weigh? So the trick here, again, I'm going to say step one. This is, to me, the most important thing. Well, assigning the variable is pretty important too. But this is a great way to start. What do we know? We have two castings. Weigh 84 pounds in total. Or they weigh 84 pounds together. We know one is 12 pounds more than the other. So that's what we know. Now, what do we not know? Well, what we don't know is the weight of each casting. Now, I'm going to make an argument, and people can argue with me on this if they want, but technically, we actually do kind of know the weight of one of the castings. One of them is 12 pounds more than the other. So if we know the more than the other, you know how much this other one weighs? All I got to do is add 12 pounds. We know what the one weighs. So the real mysterious one is the other casting. That's the real mystery. If we know that, just add 12 pounds and we'll get that. So what we can do is this. Now we can assign variables. So for step 2, we're going to let x be the other casting weight. Now, what do we know about the one casting? That means the other plus 12 is going to be the 1. Any questions about that? Remember, x is the other. All right, so now we're going to come up with an equation. Now we're told that the sum is 84 pounds. So what that is saying is that the one plus the other is 84. This weight plus this weight is 84. Now the one, that was x plus 12 from step 2. The other, the real mysterious one, that was just x. So that's 84. So add these to, and so this is the equation we're going to get. Now we're going to solve it. So you have x plus 12 plus x. I apologize, I'm going over time. I'm going to do one more example after this. If you have to be somewhere, that's okay. I'm recording the lecture, and you'll be able to watch the rest of it if you need to go someplace else. I apologize, I'm going over time here. Now again, we gather like terms. There's a type x plus 12 is 84. Subtract 12 from both sides. I'll subtract it like that. We'll get 2x equals, and this will be 72. And then divide both sides by 2. We'll get x is 36. Now that's the weight of the other casting. So this is that mysterious other. But the one casting, all we had to do was add 12, and then we would have it. So the other the one casting is the other plus 12, or 36 plus 12. That's going to be 48. So these weigh 36 pounds and 48 pounds. And if you think about step 5, that kind of makes sense. Now, if you want to check this, like for step 6, add these two together, you're going to get 84. And that's what the problem said we should get. If we take the sum of the weights, we should get 84, and certainly we do. So any questions about that? Here, I'm going to do one more, and that's it for this evening. And again, if you have to leave, go ahead. I'm going to post this video tonight, so you have it. So let's say we have this. Let's say an auto mechanic has $1,861.16 in total receipts for a certain day. So at the end of the day, you look into the cash register, these are the receipts. Now, 1,200 $1,240 of that is labor. So what's happening? You're working at an auto mechanic shop. This is how much you have in receipts. And this is what customers have paid the shop. Now they're going to pay the shop usually for two things, parts and labor. So you have $1,240 of this. That's going to be labor. The remaining is parts, and oh, they do bring in something else. Sales tax. Ooh, don't want to forget that. But the sales taxes on the parts only, not on the labor. If sales tax is 6%, find the quantity or amount of sales tax. Now there's a lot flying around here. And this is where, again, listing what is known and what is unknown, it'll help make sense of really what seems like a lot of chaos. 1,861.16 in total. 1,240 that is labor, and then whatever is remaining is parts and sales tax on the parts. Now, if the sales tax is 6%, find the quantity of the sales tax, the dollar amount. All right, let's break this thing down. Let's make it accessible and sensible. So what do we know? Seems like we know a whole lot. It's overwhelming. Well, we know there's 1,861.16 total. We know that. We also know 1,240 is labor. And the rest is parts plus parts sales tax. No sales tax on the labor. Sales tax is 6%. So that's what we know. What do we not know? Well, there's a lot of things we don't know. Well, maybe not a lot, but what we don't know is parts plus parts sales tax. We don't have that quantity. We also don't know the amount for parts. We also don't know the parts sales tax. So this we don't know, and this we don't know. We don't know what they are together. We don't know what they are individually. Now, here's the thing. If we know how much money there was for parts, we can calculate the sales tax on that amount. Now, this is where this problem's kind of special. Sales tax, I have to bring in a little outside science. Sales tax equals the rate times the amount. Sales tax is the tax rate, and this is as a decimal, not as a percent, but as a decimal, times the amount. So what this says is this. If we know how much was spent on parts, that's going to be the amount. And since we know the rate is 6%, we can take the 6% times the amount spent on parts, and that's going to give us the parts sales tax. So the real unknown here, the one that's really mysterious, is this. Excuse me, because this is going to be 0.06 times the amount spent on parts. Yeah, I apologize, excuse me. So if we know parts, that's the big unknown. So now we get to step 2. Let X be the amount of money from sales of parts. That means the parts sales tax. It's the rate. We convert the percent, which is 6%. We convert that to a decimal. It's the rate times the amount, which is parts. And that's represented by X. So that means parts plus parts sales tax is going to be X plus 0.06 X. Parts sales tax. Now, let's come up with an equation. We're told labor plus the parts and part sales tax well, the total was 1861.16. Everything in that drawer, that's what it is. Now the labor, though, they told us that that's 1240. Then parts plus parts sales tax, that's X plus 0.06X. And that's equal to 1861.16. And this here is our equation. So now we got to solve this equation. So we have this. Got to combine like terms. We have 1x, 0.06x. So the type x terms become 1.06x. Subtract 1240 from both sides. (1.06x) is equal to, let's see here, 62116. Finally, divide by 1 600, or 1.06. And when we do that, I need my calculator here. 621.16 divided by 1.06, we get $586. Now I'm going to circle this because this isn't our answer. This is the amount of money in the drawer from parts. They want us to find the sales tax on those parts. So any questions so far? All right. So the last step in this problem was going to be 0.06 times x. But we know what x is, it's 586. So 0.06 times 586 or $35.16. And that's going to be our answer. It doesn't make sense. Well, okay, we'd expect the sales tax to be less than the amount for parts. So, okay, that makes sense. And one way you can check this, if you take your labor plus the amount for parts, which we did find, that's 586, and then add the amount for the parts sales tax. Well, let's check this, see what we get. Sure enough, we get the total in the drawer. And so that works. So that's it. That's 7.6. I'm going to take a look at the homework. I'm probably going to make some adjustments. And I'll let you know what those are going to be. But that's going to be it. I'm going to I'll post the video tonight. I'm going to post, again, the test will be posted tonight, and it's going to be due Saturday. And if any questions about that, let me know. Other than that, have a wonderful evening. And again, let me know if you have any questions.